Thank you all for attending. My name is David Hunter, and today is our part 3 of demystifying color management. As you know, I like an interactive group, so if you guys have questions, please feel free to put them in the chat. Beth is going to be helping me answer these questions as we go, or at least notify me when there's questions out here so that I can stop the presentation and answer the question as they come up. So I like it to be very interactive. In terms of this presentation, it's a continuation of our last 2 months sessions. The first session was on, this whole series is on the 5 C's of color control. And the first C was all about color capture devices in terms of understanding the difference between different measurement devices, whether they're $50 or they're $10,000. Every instrument has little idiosyncrasies, and it's important to understand which instrument you want to use for which purpose. The second presentation that we gave was on calibration, and calibration is all about making a device consistent to itself. And today's presentation is, once you have your device consistent to itself and repeatable, then it's oftentimes of benefit to build an ICC profile that essentially understands the language of color that each device speaks, so that we can talk next month about the conversion C, which allows us to convert color from one device to another device, so device A matches device B. So that's more next month's topic, which is the 4th C, all about conversion. All of these C's relate to conformance, and conformance is ensuring that your measurement devices, your calibration, your characterizations are doing what they should be doing before you actually implement them in the workflow. Because if you implement them in the workflow and they're not right, you're going to be scratching your head and color's not going to come out the way you want it. So with that, let's get into the 5th C, or excuse me, the 3rd C, which is characterization. And typically the first thing you want to do is make sure that that device is stable and consistent, ideally calibrated. Ideally, you want to build the characterization or the ICC profile right after you've calibrated it. So you don't want that calibration to sit any longer than you can. As soon as that device is calibrated, you want to start your profiling process. But before you start your profiling process, you should do your due diligence on the device to make sure it's in a condition to be profiled. The other thing you want to make sure with certain types of devices is that the ink limits are set correctly. This is really important for large format, inkjet type printers, grand format, because if you have too much ink coming out on the page, it runs and it looks bad, it doesn't set up well. If you have too little ink on the page, oftentimes the color gamut, or the range of color that that device is capable of producing, is not very good and might not be acceptable to users. So I'm going to share an actual story where a customer of ours bought a number of production inkjet printers to deliver print for a big brand company's campaign, which had red as an important brand color, and the ink settings that they had on this production inkjet printer was in the economy mode. So the level of red that came out of the printer was horrible. And the brand company said, absolutely not. You're not printing this for us. We're going to revoke the contract. And so we worked remotely with the printer to figure out an ink setting on the device, which wasn't as economy minded, but at least they saved the job and the customer, and it was a $100,000 deal. So it worked out, but we had to help with the ink limits to get the gamut so they could get the color they wanted. So it all plays into one another. So the first step is verifying the printer. Second step is verifying the substrates and qualifying the substrates. If you guys are printing digital, chances are you're printing multiple substrates off the same digital device. This is from one of our customers. They print 45 different substrates on one digital device. Now, if you've been, keeping up on color management, some of you might be thinking, oh my goodness, do I need 45 different ICC profiles to represent these 45 conditions on this one printing press? And the general consensus would be, well, yeah, that's what you do. You profile each print condition, i.e. printer, paper stock combination, because they produce different color. And especially when we get into foils and very unusual type substrates. But now you say, well, that's a nightmare. 45 profiles? There's no way I'm going to be able to do that. And this is where you can qualify the substrates into different categories. And based on your expectations of a color match, you don't have to build 45 different profiles. You might be able to get by with 6 profiles that represent these 45 conditions, depending upon, again, your expectations for a color match. And we're going to talk more about how to do that and show you the different processes to do that. Next thing you want to do is, now that you know which substrates you want to profile and your device is stable and consistent, now you need to choose your characterization software in terms of what software you're going to use to build the profile. There's free software programs on the market that build ICC profiles. There's software programs on the market that cost $10,000 to build ICC profiles. And the type of ICC profile you want to build also plays into it. Is it an RGB printer profile? Is it a CMYK printer profile? Is it an extended gamut profile, meaning it's printing with more than CMYK inks? And typically I'm not talking about a light cyan and a light magenta. I'm talking about an orange, violet, green, blue, what have you. Like my Epson over here has 8 different ink cartridges, 7 different type colors of ink. But when I profile it, the RIP takes care of everything for me, the channel splitting and so forth. So the RIP that I have for my Epson, I can't even profile it in an ECG or extended color gamut capability because the RIP doesn't allow me to. And that's often the case with large format devices with a light cyan or light magenta ink. You treat the light cyan with the cyan, and it's still a 4-color process. Now, when we get into specialty types of printers that allow you to load additional colorants in there, as well as any conventional types, flexo, offset, where you're doing extra inks to get that extra gamut, then you want to look at profiling software that can handle that type of thing. Next, we decide which profile target we're going to use. The standard on the market is what we call the IT875, which you might know as the TC1617, which looks like this. And this target is actually formatted for my ISIS measurement device or my Konica Minolta Miro 9. So, but I couldn't read that target I just showed you with my i1 Pro. Now, I could read that target with the right software, with my scanning exact, with a 2mm aperture. So again, you need to figure out which profile target you're going to use, and it needs to be compatible with your measurement device. And when we're talking about measurement device, I'm going to chime in here that you want to make sure that when you're building the profile, you're thinking ahead, that when you're doing it, the quality control check after the profile is done, that the measurement device that you're using to do the QC is in line with the measurement device that you're using to build the profile. Because I can tell you, it was probably 15 years ago, I was working with a customer of mine in Stillwater, Minnesota, just down the road, and they had built ICC profiles with a Barbieri, and they were verifying the profile with an i1. And the delta E's and the E factor was unacceptable right out of the gate. And they're like, whoa, what's going on? And what we figured out was that the solid cyan of the way their printer was printing on and measured off the Barbieri. So we measure the solid cyan off the Barbieri, and then we measure the solid cyan off the I1. It was showing a 3.5 delta E difference for that same color. And both instruments were measuring correctly. So you need to ensure that the instruments are aligned so that when you start mixing and matching prints and characterizing your printers and verifying the printers, that your instruments are not playing a role in making a huge difference between these situations, because it's telling you there's a huge difference, but visually it's identical. There is no difference. So it's what we'll call a false fail, and that the instrument tells you there was a problem, but there's really not. It's the fact that your instruments are not aligning to one another. The next thing I'll mention is you'll typically want to print your target multiple times, especially if you haven't benchmarked the printer before. And last month we talked a fair amount about benchmarking, because benchmarking gives you the ability to really understand the idiosyncrasies of your printing devices and understand if there's amount of variation from the first sheet to the 200th sheet. I have a customer that they were looking for very precise brand colors, and they didn't realize that the printer that they're using, a digital press, warms up after about 200 sheets, and the color shifts a 2E factor, and yet their tolerance was about a 2E factor. So what I had to tell them was, you need to let it run 200 sheets, and that 200th sheet you're going to profile. And they're like, well, what should we do with the sheets 1 through 199? I'm like, throw them away. They're no good, because that printer is still in a state of variation until it levels off at that 200 sheet. And they're like, wait a minute, that seems really stupid. I'm like, you should have figured that out before you bought the printer. Don't shoot the messenger. So every printer's got its little idiosyncrasies. And by the way, this printer is a pretty well-known printer that's used digital press that people, there's a lot of them out there. So I don't want to drag anyone's name through the mud, but buyer beware. And then after you've printed multiple times, ideally you measure multiple targets, you compare the difference. So many people say, oh yeah, always average. Before you average, compare the difference. If the comparison is within your expectations for a color match, then go ahead and average. And now that you've got the average data, then you can go ahead and build your characterization for that device, which then turns into an ICC profile, which defines the black replacement of the CMY, the black start, the total ink limits, things like this. So in a nutshell, these are the steps that you want to go through to build a characterization data set for your printing devices. And now we're going to get into some more details related to this and actually do some demonstrations. So when we're talking about characterization, it's a demanding process. You'll see there are a number of steps there, and ideally you shouldn't short circuit those steps. So the most important thing is ensuring that that printing device is precise and repeatable. The next step is assessing the effect of paper stock on the result. Paper is that 5th color and 4-color printing, so you want to make sure that paper is relevant to what your job's going to be. Next, you build or choose ICC profiling software and configure it. And why are we doing this? Because every device speaks its own language of color. So here I've got 2 different printing devices. If I give it the same CMYK values, I get 2 very different results on the printer, because as we've talked about, each printing device speaks its own language. One speaks French, one speaks Swahili, one speaks German, one speaks English. we've got to be able to understand what the language of that device is versus that device. And we do that by defining the gamut and the print condition, which is a culmination of the ink and the substrate, the calibration, the ink limiting within the printer. And then once we have that, then we can go ahead and determine if there's other substrates that share that same gamut within my color expectations, my E factor. And if so, I can reduce the number of profiles I need to make and save myself a lot of time, because every time I reduce the number of profiles I make, I also reduce the number of workflows I have to configure for the files to go through the system to go to the printer. So if we can reduce from, let's say, 6 profiles to 2 profiles, I can streamline a lot of work because I have 4 fewer workflows. I have 4 fewer profiles I have to maintain. It really makes a lot of sense because there's very few people that have a job description where they can edit color all day long. So we need to make it capable but efficient. Now, when we're talking about baselining printing devices, and if you weren't at last month's session, I'd encourage you to go back and listen to it, because we talked a lot about how to understand the variation of the printer, because you have multiple types of variation. You have within sheet variation, which is the difference within a single page. And if you look at the picture I have here, I don't know if it's showing well, but the upper right is more purple, the lower left is more green, the bottom is more pink. There's a lot of variation going on in this printer. And this was a picture taken some years ago where a very large company had brought me in to help them with profiling their printer because the profile wasn't working. And the first thing we did was we printed a page like this, and we printed it out, and we all looked at each other, and they're like, we know why it's not profiling correctly. It's like, yeah, it was pretty simple. I mean, literally, I was in there 5 minutes, and they figured out that the printer was not imaging consistently across the page, and it was a head height issue. So it was printing higher on one side of the table versus the other side, and that was causing a variation. And that's just the within page uniformity variation. But of course, we have between page and between job variation, which can be due to temperature and humidity and other types of variables like that, which of course you want to track with a device like a data logger, which tells you what the temperature and humidity is, and ideally warns you if the temperature and humidity goes outside the parameter that the printer is built to work within, so you can fix that before the printer starts varying off the condition that you profiled the printer in.
Hi, Dave.
Yes.
We have a question that does each substrate group require separate calibration?
Oh, that's a real good question. Oftentimes, no. It kind of depends.
Oh, no.
You're muted.
Dave, you're muted.
Yep, yep, someone told me. I got it. Thank you. I don't know how I did that to myself, but that's okay. So how much of my answer did you hear?
Nothing.
Nothing. Okay. Okay, so does when you're doing different paper stocks with different groupings, do you need a different calibration for every paper stock? And it really depends upon the type of printer it is. Most printing devices, no. You can do one master calibration on one consistent paper stock and verify that master calibration is working, and then run different paper stocks through there to accommodate the different types of substrates that you're printing in your process. Now, that's not true in all cases, and that's why with color and printers, it's a little tricky. But in most cases, you can get by with calibrating on one stock and applying it to other stocks. Obviously, with large format, again, you have to be careful, but within the grouping, if one of the big differences that makes the profiles work similarly for the different paper stocks is the texture or amount of gloss on the paper. And so if you can imagine, keeping things really simple, you'll have if you have got, let's say, 10 substrates, let's say 5 are coated and 5 are uncoated, chances are you'll have 2 groupings, one for the coated, one for the uncoated. Now, in this scenario, you'll probably have a different ink limit for the coated paper than you do the uncoated paper. So from that standpoint, you might have 2 calibrations for like a large format. But if we're dealing with it more like a digital press, no, you can typically just do 1 calibration for almost all paper stocks. If you have specific printing devices and RIPs that you want to learn more about, feel free to email me and we can go through your specific situation. So I keep referring to, is it within your expectations? And this is such a key part for any type of color management, is you want to make sure that the color match that you're providing will meet your customers' expectations. And so this is what we call E factor. And if you weren't in our previous sessions, you can go out to our website and there's an exercise on the website that allows you to do a E factor exercise that quantifies what your expectations are for a color match. The bigger the difference, the larger amount of variation you're willing to accept as a color match. The smaller the difference, the pickier you are, and the tighter your color match has to be in terms of meeting your expectations. So there's 2 aspects here. There's the subjectivity, human subjectivity of how close is close enough to be in an acceptable match. Once we quantify that, then we can apply it to the print process. So in this case, let's say I'm trying to make my printers aim for Grackle. If my expectation is a 4, and I have one printer matching to Grackle to a 3, and I have another printer matching to Grackle at a 5, I can guarantee you that the printer that's printing at a 3 will be acceptable to the person looking at the match, whereas the printer printing at a 5 probably will be unacceptable to the person looking at it. So this E factor is a type of delta E that quantifies color difference. The bigger the number, the bigger the difference. And so in the same way, we apply E factor to our substrates. So this is how we qualify how many profiles we need for our substrate. So what we do is we take a target, typically a simple target like a what we call a CC84, and this is a version of the CC84 on this target. It's a single strip. This one's built for a scanning exact, but we also have in a 3-row target that's quite popular with the I1. And as I pull out a board here, you can see this board. Here's the CC84 for an I1 on this board. And so what you do is you print this target on all your substrates with the same printer. And then you measure those in, and then you group them. And the slide here goes through the steps. So you've got it in the recording. And once you've got the measurements loaded, you then select them and you say, you go into what we call our print condition qualifier. And when you go into the print condition qualifier, it'll take those, in this case, 5 different substrates. And I set my E factor. So I set my E factor to be a 3. And so by setting my E factor to a 3 for these 5 substrates and then clicking on confirm, the ChromaChecker software will say you need 3 groups. So the poly needs its own profile. Group 2 is the semi-gloss and the high gloss pharma. And group 3 is the thermal and the Kimdura. So in this way, for 5 substrates, I need 3 profiles because I'm looking at a fairly tight tolerance of a 3 E factor. If I change my E factor to, in this case, a 5, So I'm saying I'm allowing more variation. I'm allowing for more color difference. For these 5 substrates, I only need 1 profile. And the way this is organized is the top file in the group, so the poly, which is at the top of the line, is most like the other 4 substrates. So that's the substrate that you profile. Now, could you, if you wanted to, take the IT875 target, print it on all these, measure it 5 times, and then average them? You could, but the value of doing that versus the time is not worth it. Just by taking the poly profile and using that one workflow, because remember, not only is it just one profile, but it's one workflow now. So you have one workflow that relates to 5 different substrates that you're printing on your printers. I had a customer in Duluth who the technician was saying, yeah, I've got eight substrates here, and if I do a 3 E factor, I need 4 profiles. But if I do a 5, I only need 1. And I'm like, well, what's your boss's expectation? What's the owner's expectation? And he said a 5. And I said, do you have a lot of spare time? And he said, no, I have no spare time. I'm like, why are you fighting the owner? If the owner's a 5, you shouldn't be a 3. Be a 5, do 1 profile, save time, deliver the expectations that the owner's looking for, and now you've got time to do other parts for your job. You don't have to be building 3 different profiles and then building 3 different workflows and then educating your users on the 3 different workflows for these substrates. Just keep it simple. 1 profile based on the poly, 1 workflow, and everything's all good. All right, and here you can see if I change my E factor to a 2 and say recalculate, I'll need 5 profiles for the 5 substrates. So it makes total sense. The bigger the tolerance, the fewer profiles, the tighter the tolerance, the more profiles, the more work, the more energy, the more money it's going to cost you to do. So only make it as good as you need to make it. Next thing is choose the characterization software. ChromaChecker, a lot of our customers don't know, ChromaChecker now has ICC profiling software built in. And it's accessible from our Capture software, which is the client software that interfaces with lots of these measurement devices that allow you to measure the targets and tell you whether or not the print's right or wrong. But today, with Capture, if you measure a target which has G7 gray finders like our CC84, so this CC84 target I showed you, this is like a P2P in that at a fraction of the amount of patches, a P2P is 300 patches, this is 80. So what, P2P is about 4 times the amount of patches, but we can generate an ICC profile from this, or excuse me, a G7 curve from this target in seconds, right from Capture. And now in Capture, if you measure an appropriate target with an appropriate number of patches, Capture can actually build an ICC profile for the operator on the fly. Most people, you'll do you'll plan it out more, so you'll print our the IT875 target on the appropriate format for your instrument, and then you'll ideally print it right after the calibration is done. You'll ensure color management is turned off on the RIP so that we're getting the full range of color that the print is capable of providing. I always recommend putting a color bar, some sort of color bar, on the page that your ICC profile is printed on. By doing this, when you build your ICC profile, you can also measure the color bar, and in ChromaChecker, label the color bar that this was done at the time the ICC profile was built. So down the road, if you think you might need to rebuild the ICC profile for the given print condition, you can compare how the printer's printing from last time we built the profile to this next time you think you're going to build it, and get a real good E factor of knowing if that device is drifted, if the cyan's imaging the same way it was. Helps you troubleshoot problems really easily if you always put a color bar that you're capable of reading with your measurement device on the same page as your profile target. That's why when you look at these targets that I showed earlier, each of these I use the profile, but I also have a QC bar, this CC84 bar up along the strip that I use with my exact to keep track of how the printer's printing. And oftentimes, we did this, I got a screenshot I can show you, where we actually printed this target on 30 different substrates. And all I did was measure this bar 30 times, which is about 10 seconds per bar. And then I use ChromaChecker's grouping capability to group the prints, and then we organize them in the groups. And I'm going to kind of go off script here and look for this picture quickly. If I can find it here, because I think it's really helpful. Yeah, here it is. So here's the grouping of the 35 different prints, and we were grouping them in different sections. And notice I have pictures on these pages. And so here's Mark. He's looking at the print, and they went in saying we're an E factor of a 3. And I'm like, okay, guys, you're kind of new to this color stuff. 3 is really demanding. It's going to be a lot of work, a lot of effort. You probably don't want to be a 3. And we did the 32 substrates, and at a 3, they needed 16 profiles and 16 workflows. And it's like, I just don't see that happening. If you go to a 4 E factor, so let's crawl before we run. Let's go to a 4 E factor and let's see what the differences are. And at a 4 E factor, we went from 16 groups down to 7 groups for 30 substrates. So an average of about 4.2 substrates per group. And what we're looking at here with these 5 prints here is these all fall into one group. And their color guys were looking at it to see if they could live with that much difference. And they did, thank goodness, because trying to implement color management at this shop with 16 different profiles would have been a nightmare. It would have failed. And it's why color management often fails, is because people bite off more than they can chew, and they get frustrated and they can't make it work in the workflow. So this helps minimize that. And after you have the groups, the next thing you want to do is compare the elements in the group. And when in ChromaChecker, after you've measured the data and it's been loaded into that, in this case, is Xerox track. So you'll see the Xerox track has 3 different measurements in it. I can then click on these measurements and say compare. And this is another way of doing a compare. The first way to compare is what we call the print condition qualifier, which I was sharing back here, where it shows you grouping automatically. But this is a more simple way where I'm taking my 3 prints and comparing them to one another. So this is print 1 to print 2. It's a 0.2 E factor. Print 1 to print 3 is a 0.2 E factor. And print 3 to print 2 is a 0.1 E factor. So this is telling me absolutely how close are each of these prints to one another. And in this case, a 0.2 E factor is fantastic. So then I can take that data and I can then group it. And then once I've grouped it, I give it a name. And then I click on, so in this case, I made it a name iGen average. And then I go into the magnifying glass and you'll see there's a create ICC profile button here. And it shows me all the values for how this printer is printing these pages that I'm going to build an ICC profile. And when I click on the ICC profile, ChromaChecker comes up and gives me the ability to set the ink limit, the black start, black max, the GCR, and then I can go ahead and say export. and it's going to export the data to my directory of choice. And it'll also put it in the ChromaChecker ICC Profile Inspector tool. So ChromaChecker's ICC Profile Inspector keeps track of all your profiles and gives you the ability to then say, hey, what percentage of the Pantone colors are capable of being rendered in this iGen coded profile? And it'll come up and it'll say 55% are capable of being rendered within a 2 delta E. And then it shows you which ones are 8 delta E, which Pantone colors are 8 delta E off versus the ones that are in gamut. Real helpful things like this. And also within the ICC Profile Inspector, it gives you really interesting data, like what is the gamut size of the printer? Because if you can imagine, if I'm trying to use my iGen here to simulate Grackle, Grackle has a different gamut, has a different and a specific gamut size. And I want to see if my iGen has a larger gamut than that of Grackle so I can accurately represent it. If the iGen has a smaller gamut than Grackle, I can't artificially make a printer print more colors than it's capable of. So you have to have that extra color to begin with so you can strip away or ignore the extra color when you're going for a color match to make the iGen match Grackle to a tight E factor. So knowing the gamut size is important. Also, there's something called a round trip integrity check. And what this does is a profile, of output profile is actually made of 2 parts. And this is going to sound a little technical, but there's an LAB to CMYK component and a CMYK to LAB component. And depending upon how you're using the profile in the workflow, that will determine which table of the profile you're using. Well, ideally, the table of putting color data, LAB data into the CMYK and extracting LAB out of the CMYK should result in a net of a 0 difference. Well, our math is not perfect today, not even close. No offense to profiling software creation. But you, in today's higher quality level of profiling, you should be expecting an E factor on the round trip of less than 1. So that means the 95th percentile of the input color to the output color is less than 1 delta E. That's reasonable. But some low-end profiling software programs, you'll see 5, an E factor of 5 when you do the round trip. And this makes you, this needs to make you question, okay, what is my expectation for my workflow? And let's say my expectation for the workflow is a 5. If the round trip calculation in my profile is a 5, I can't trust that profile in my workflow. You're using up your entire tolerance based on the round trip error in the profile. You can't do that. So this is another beauty of the E factor, is it allows you to quantify the quality of profiles based on the quality of your workflow. In the same way we talked 2 months ago about, you can quantify the variation of your instrument in E factor, and that E factor variation of the instrument plays directly into the E factor variation you're willing to live with in your workflow. So all these numbers play into one another and help you make decisions about, yeah, I can't use this profile, or don't even deploy this profile in the workflow because we know it's not going to work. The profile inspector also allows you to do profile comparisons. And I'll probably demonstrate a little bit of that because, you know, when we moved from Grackle 2006 to 2013, 10 years ago, if you remember that, people were like, well, what's the difference? What's the difference? And people in the industry would say, oh, it's really similar. And I'm like, oh, I hate that. I hate when people, oh, it's really similar. What does that mean? To who? It's not, I've got brand buyers that are a 2E factor. It's not really similar. A 2E factor is not really similar to them. Might be for a common person, but not for a really critical brand person. So we can do an E factor comparison of Grackle 2006 to 2013. And guess what the number is? It's a 2, meaning 95% of all the colors in this target are within a 2 delta E, but there are certain colors within this target that go beyond a 2 delta E. And so these are things that you need to be aware of when we start making decisions in terms of, okay, I've got 3 printers set up for Grackle 2006. I got 2 printers set up for Grackle 2013. What does that mean in regard to the difference between the printers set for 2013 and 2006? Well, right off the bat, they're off by 2. I can guarantee you that, minimum. Because if they were all perfect, meaning 0 E factor to Grackle 2013 and 0 E factor to 2006, they're going to be off by 2. Well, trust me, no printer's a 0 to any standard. And part of that is due to the instrumentation, because the instrumentation used to build the standard is not the same instrumentation you're using to build your profiles. So right there is error, and so yeah, I gave a presentation a couple of years ago at the color conference called "So You Want to Be a 2 delta E Tolerance," and I went through all the reasons why you, for the most part, you can't be a 2 delta E or 2 E factor tolerance, because the industry standards don't allow for it because of this variation between instruments and between light blues and so forth and so on. We're not at the ability to do less than a 2. Now you can, if you take control of everything and you understand and can track the differences as we're talking about, you can get there, but not without a whole lot of work. All right, so in summary, planning and execution is critical for success when you're dealing with building characterization data sets for profiles. Remember, you need the right target. Remember, you need the right instrument. It needs to be relevant to the one you're going to be using to verify how that printer is printing over time. You need to measure these targets precisely. Always compare before you average. Always compare. I hate when everyone says, oh yeah, just average the data. It's like, I've seen situations where one curve was 10 points above, one curve was 10 points below. When you averaged it, it was passing, it was perfect. But nothing worked on the press after that, because the press, there was so much variation in the press, it didn't work. So don't blindly average. And then once you have the profiles right, then you'll load them into your workflow, set up workflows relevant for the substrates you're using, and you will get your color to meet your expectations. So I saw a couple questions come in here. So let me quit out of here. One of the questions that I see here is that this customer has like multiple printing devices printing on the same substrate, and they're asking, do they need different profiles, even though they have like 6 of the same printing device printing on the same substrate? They're asking if they need multiple profiles. So I actually have an example that shows this. So I'm actually going to go into ChromaChecker, and I'm just going to log back in because it's been a little time since I've logged in. So I'm going into our ChromaChecker system and I'm logging in, and I'm going to go to our print inspector because that's what we're looking at right now. We're looking at prints, and I'm going to make a new track. We'll make a new track underneath this press. So we're just going to quickly duplicate a track, and I'm going to put sample here. And so now I have a track with no data in it. It's aiming for Grackle. And what I'm going to do is go to my cloud icon, and here I have some data. And I'm going to pull in this data. This is the 12647-7 target. So the Idea Alliance control strip printed on, I think, 12 different Roland printers on the same substrate. So I'm taking the measurements that this customer had done on these 12 different printers, and I'm loading them in. And you can see ChromaChecker is now tracking them, and they're about 9 E factor different from Grackle. That's okay. Obviously, they're not aiming for Grackle, so it's not a big deal. But what I really care about is, are these printers close enough? So in fact, as I'm thinking about this, I don't think that this target was color managed. So another reason why it's 9 out. But the purpose here is not to judge it against Grackle. The purpose here is to judge it against itself. So what I'm going to do is click on select opposite here. And by saying select opposite, it selects all the files. And then I'm going to go into the PC qualifier. This is the print condition qualifier. And when I do this, it shows me the 11 printers, and I'm going to say E factor of 3. And when I say confirm, ChromaChecker says, I only need one group. All 13 files are within a 3 E factor. So I'm good. I just need one profile to represent all these roll-ins. And roll-in number 10 is the top one on the list, which has the smallest standard deviation. So that's the only one I have to profile. And they did this years ago now. This is a real life customer who he went on the ID Alliance forum and asked this question. And he had a bunch of answers or secondary questions come back that never helped him. And I showed him this, and he was like, oh my God, this is exactly what we need. And he's telling me that when parts need to be replaced on these other roll-ins, they replace the part, they do the verification scan, and it's done. They don't have to update their workflow. They have one workflow. They do load balancing on all these printers. It's all perfect for them. Now let's do a different example. Let's do an actual substrate example. So I'm just going to quickly delete these files I just brought into this track, and I'm going to go grab some other data. So here's another situation where this company had multiple HP printers. So let's alphabetize this so I can see. So here's they had what, 5 HP latex printers. So I'm going to click on the again, any color bar. It could be the P2P, it could be the IT875. So here's now my 5 latex printers. I can see how close they are to Grackle or how close they aren't. But no matter, I'm going to click all of them, and I'm going to do PC qualifier again. Let's keep it a 3. And as I come up, it says, okay, 3 groups. This latex is in one group, this latex is in another, and then these 3 latex all fall in line. So I can go take a look. Well, what's the difference between this latex AQ with these? And I look here, and it's a 10 E factor. It's a 10 E factor between this latex and these 3 latex. And the difference between this top one and the bottom one is 5. So that's why these 2 latex printers are kind of off in left field. They were supposed to be printing the same. They're not. So we can safely assume these 3 are printing right. These 2 are not. So we need to focus our attention on these 2, fix them so they come in the line with these. And this is all before profiling. By aligning them with their ink limits and their calibration and all their internal settings, when I go to build the profile, now when I get them to match, the batch will be that much better. So remember, I'm doing this from a raw standpoint of how they're not matching. And to accentuate this, I'll show another example where this company had bought 6 production inkjet printers. And this is the example I started with. And they were in 6 different locations throughout North America. And they were already installed. They weren't printing color to the way the brand was liking it or accepting it. So we had to remotely play with the printer's settings to change their ink settings. And here's the actual example. It's actually Here's the 6 different printers. And this printer here, it was in one of their locations. And this was the data set from the profile target. So before we built the profile, we printed out the target, we measured it, and then we're measuring all of these printers in 6 different locations, how natively they print to one another before we build the profile and apply the workflow. And you can see this printer 10, 10, 12, 11, 11 to the other printers in the network. This is way out of left field. Don't even spend a second building a profile from this printer. Now look at this printer. This printer to that printer is a 3.2. This printer to that printer is a 3.8. This printer to that printer is a 3.3. This printer to that printer is a 5. Then 3, 2, 3. So here you can see that 5 of these 6 printers are actually natively printing very similarly to one another, even before we apply the ICC profile. And so once we build the ICC profile, then they're even closer. So this is a way to do a comparison to see the differences. And if I wanted more information, so if I wanted to just kind of see why this printer is so much different from that one, I can hit details. Oh, it's been too long since I logged in. So let me just quickly log in here and let me go back here. I'm going to go to my, I was actually in my ICC profile inspector here, and I can go ahead and choose these printers. So I'm in the ICC profile inspector, it gives you all the information about the type of profile we're working, the printer we're working with, and the profile. And I'm saying compare these printers profiles within ChromaChecker. And here we go back to that table that you just saw. And if I click on details, it's now going to show me that the delta E differences on the cyan, magenta, yellow, and black are here. Look at the black is a 7 delta E difference. I can see that this black, this one is, well, Toro and Boise is a lot darker black than this printer. And I can see that when you render the same color through both printers, it's a 10 E factor. And then right here on the gamut view, I can see one printer is dramatically smaller than the other. So the ink limit was off on this printer. Right away, I know the ink limit was off on this printer. We need to reset the ink limits, re-output the profile target. Don't even try to profile it. Don't put it in the workflow. It's going to be wrong. So this is all doing it through the profile inspector. So these are ways that you can be intelligent about knowing that your profile is right. You know, we talked about the round trip calculation. Here's the round trip calculation. You can see, you know, both profiles are relevantly good. The E factor is 1.5. I said we wanted to be more in a 1 range. It's not terrible. This one's a 1.03. So there's nothing inherently wrong with the profile. What's wrong in this case is that it was profiled in the wrong condition, meaning the wrong ink limits were set. So before I ever tried to test the profile, we said, no, it's not good. Test isn't going to work. We need to redo it. Are there other questions that people might have related to ICC profiling and anything in my presentation that I've talked about? Any other questions that people have on profiling? Well, if there are no other questions, I want to thank everybody for your time. I hope you found this session enlightening in terms of how to go about setting up your printing devices so that you do profile them correctly, and how you can check the profiles after you've built them to make sure they're going to work in your workflow, and how to minimize the amount of work that you need to do if you're dealing with multiple substrates and multiple print conditions. Work smarter, not harder. Remember, with ChromaChecker, you can log in for a free trial. All you need to do is go to our homepage, and there's a register button. If you go to the register button and register your name and company name, we will set you up with a trial version of ChromaChecker. We have over 200 videos on our site. You'll be assigned a coach that will help you start getting up and running with ChromaChecker. One of the first things I'd recommend you do is take the CC84 target and print it on all your conditions, print it on all your printers, print it on as many substrates as you can, then start measuring this data into ChromaChecker. Then ChromaChecker can do the comparison. You can see how close your printers are hitting Grackle, how close the printers are hitting one another, which printers are most out of line that need to be adjusted to bring them back into line. So those are the printers that might need the profiling. All this type of data is instantly at your fingerprints with the ChromaChecker platform. And as I said, we give all of our customers a 30-day free trial so you can see for yourself how easy it is to use. So if anyone has any other questions, feel free to email me at david@chromachecker.com. We will have this video posted sometime tomorrow, so that if you want to share it with any of your associates, you can. Again, I want to appreciate everyone for your time with us today. I hope it was helpful, and hope to see you next month when we talk about the conversion C and how you can plan and customize your conversions based on your goals for your color control system. Thank you.